The broadcast is now starting. All attendees are in listen-only mode.
Hi, this is Richard DeMark, and welcome to today's CMG webinar sponsored by IntelliMagic, titled How to Transform RMF and SMF into Availability Intelligence. The speaker today from IntelliMagic is Brent Phillips. And Brent's been working with IBM mainframes for over 30 years, starting in operations while at the university and later as a VTAM systems programmer. He's been with IntelliMagic for over 10 years and is responsible for the IntelliMagic business in the Americas region. So the way we're going to do this, I'm going to turn it over to Brent in just a second. But if you have any questions, use the little chat window that you see on the GoToWebinar, and we'll get to the questions as soon as possible. So Brent, it's all yours.
Okay, thank you very much, Richard. Appreciate everybody joining us today. Let me see if I can, there we go, advancing the slides. Yeah, thank you very much for joining the webinar today. Here's, I promise not all the slides will have this much text on them. I just wanted to put this abstract back in the deck, so it will be available on the CMG website after if it's not already there, to download for people that may have missed it or want a reference. So, and maybe as a refresher for those of you that were able to join us today, I mean, we are talking about a new, more intelligent approach to interpreting the RMF and SMF data in order to outsmart unavailability. So that's the topic that we're discussing today. So it has to do with, of course, availability on the ZOS. This is a platform that's known for its reliability and scalability and so on. In fact, usually in a live audience, I like to ask, you know, what the Z stands for, to see how many people realize the history of that, at least according to Wikipedia. In this case, everybody's muted, so you probably said the right answer. But anyway, here it is, zero downtime. I mean, this is something we're proud of when we work on the mainframe platform and the stability and so on and so forth. But the question is, you in the real world maintaining the mainframe environment, the performance and configuration of it, what is your experience? Does that mean that you never have any incidents that lead to unavailability? And of course the answer is yes, those incidents still occur despite the advantages of the platform. And the difference is really perhaps ZOS versus the application kind of environment. So ZOS itself may stay up pretty much all the time except for unplanned downtime. I mean, if you look at the 4 nines, that's like 52 minutes of unplanned downtime per year. 5 nines is 5 minutes per year, and that's actually can be achieved by some sites regarding the operating system level. But we're very familiar with different environments in our customer environments where issues come up on a regular basis, where at least a portion of the users, whether they're employees or customers, are unable to access certain parts of the infrastructure, applications, or transactions due to performance issues or unavailability issues. And that's what we want to talk about in a little more details today. And the point, of course, is that there's many different parts of the infrastructure that need to be operating properly in order to deliver those kind of service levels that those performance-sensitive transactions require or applications require. So they're listed here on this page, and we'll get into more details about those. I think an initial way to describe the problem that we like to talk about is these issues that cause any kind of application unavailability. How many of them are predictable and how many are unpredictable? Today you probably think of most of the incidents that cause some kind of unavailability as being unpredictable. And that's because you find out about the problem only after it's already affecting that production environment. And so ideally, if you could predict it, I mean, you can take an action to avoid the incident, you know, when you see it coming. But most of the time it's spent down in the red environment with these kind of incidents where we just are seeking to find out about the problem as early as possible before it gets worse, before the phone starts ringing off the hook and more people find out about it. And how do we accelerate the fix of those kind of problems? So blue is obviously better than red. Blue represents the calm waters where we can think more clearly and make a difference to save people from experiencing pain with the systems and avoid the really high pressure urgent fires that's represented by the red. And so the question really is, how can we convert this pie to have more of the blue rather than red, enlarging the blue slice so that most of the incidents that we deal with are predictable and we can take this proactive action to actually address them before the pain is felt by the end users or before they ever experience any kind of outage or unavailability levels. So what would that mean for your IT staff, for you guys that are solving these kind of problems? Obviously, it would help you maintain some sanity a little bit easier for employees as well in terms of their productivity and satisfaction with the IT systems, and of course, perhaps most importantly, for the end users that are using revenue-generating applications in the organization. It's obviously critical to keep those available at all times. So this is actually fairly easy to visualize the difference that this kind of transformation would make on these people. The question is, really how can it be achieved? I mean, your organization is probably like most organizations that's invested 30 years or more in reporting on the performance and configuration data, the RMF and SMF data, building a PDB to help understand how the infrastructure is handling your workloads, and yet we're still at this point where we're unable to see most of these incidents until they've already impacted the production environment. And that's why we at IntelliMagic say it's time for a new approach to leveraging this RMF and SMF data, which is the richest source of machine-generated data on any enterprise computing platform, and how can we utilize that in a way that can significantly reduce the amount of unpredictable incidents that cause this unavailability in the production environments. So we think it's useful actually to correlate it to how we deal with the security problem. I mean, they're not just dealing with security incidents that have already breached the walls and are causing problems. They also go through a detailed analysis of what are the threats. How do you monitor the threats? And so I think it's useful to talk about an analogy here in the performance and availability arena to compare, which has better intelligence to avoid outages, a $20,000 automobile or a $20 million mainframe. We would like to say that the more expensive mainframe does with all that's been invested in the platform and everything we know about it. And yet if you look at a dashboard of an automobile, this if you know your cars, this happens to be a Porsche 911 dashboard, so it's not a $20,000 automobile. In fact, probably the dashboard by itself costs $20,000. But nevertheless, the concept is the same. Pretty much any car you buy today has this set of gauges that will include essentially some built-in knowledge about what's good and bad. You don't have to find out that the motor has a problem with the amount of oil in it by the engine locking up and the car stopping. There's oil temperature gauges, oil pressure gauges. An uneducated driver is going to be warned that there's an issue before it affects the ability of the car to keep producing, why you have a car, to go from one place to another. That's not the case with the mainframe. We have lots of data, but it's a problem of what does it mean for how my infrastructure is handling my peak workloads and getting that advance notice that, hey, there's a critical bottleneck developing here and you need to do something about it now before it causes a more serious problem. Another analogy in the auto industry that kind of useful to think about is also not with a $20,000 car. I think this is a screenshot from a BMW feature, but it's also available on a lot of cars. It's really a new source of data, infrared data out of the car and interpreted into a visual fashion to be able to let you see what cannot be seen with the naked eye. And in this case, obviously, it's quite important to be able to swerve and miss the human in the road, and so you want to have that early notification of that. Obviously, if you hit an object with a car, it doesn't have to be a human, but you have airbags, and whether it's a standing object or whatever. But it's always better to see things in advance and be able to swerve around it than to have the airbags go off. So bringing it more back to our environment that we operate in today on IT infrastructure availability. How do we monitor it? What's the real cause of the issue of why we're still experiencing these unpredictable disruptions to the service levels that our applications require? And this is really the root of the problem from our perspective. It's that the existing monitors look at the symptoms at this stage. After something like the response time is high up in the red area here, that's when the triggers are set to go off, and maybe the phone rings even before this stage when other people notice them. So that's kind of the focus of pretty much the newer types of solutions, to be able to get what they call early warning. It's early warning of a problem that's already affecting the production environment. The reason that everybody's monitoring this kind of metric is it's easy to get. But the point is it's an effect or a symptom. It's not the cause of the problem itself, and consequently you can't really see it or detect it until it's already affecting that kind of environment. So with what we're calling this area of availability intelligence, it looks at something different. You want to look earlier in the cycle while these response times are still low. How can you find out that there's an issue developing in the infrastructure to handle your peak workloads before the response times go up? Well, it's actually easy, right? You just look at all the components that are involved during the peak periods and see which ones are approaching their saturation points, and getting to that point where they're going to start to introduce delays into the response times, so that you hit this knee of the curve and that shoots up. You want to find out about it here in this range. And of course, I'm somewhat joking about that being easy. If it was easy, everybody would be doing it today. It would actually take an army of deep experts who understand the workloads and the flavor and the characteristics of them, understand the hardware and the components and their limitations for handling those types of workloads. And it's just simply not feasible to do that kind of performance and capacity analysis and daily monitoring in a manual way. So yeah, it requires looking at every data point in the infrastructure with that expertise. So how do you change the outcome? It's by having a way to automate that kind of process of applying that type of expert knowledge to the data to look at the root causes as opposed to the symptoms, and then to be able to get both the saturation of the components, to be able to recognize that as that's starting to approach those levels where it's going to introduce delays, come up with a remediation strategy to deal with that, and then allow the response times to continue to be delivered by the infrastructure for those workloads in the range that is acceptable for the applications. So what does it mean for the IT staff? Today, in general, we feel there's basically two states. You're either pretty much happy with how the infrastructure is handling your workloads, and you're free to do what you think is important, or you're very unhappy and completely consumed with solving the problem. So the issue is it's pretty hard to focus properly just for the human brain when we're in a crisis or kind of a panic mode. It's so much better to be able to think about it when we're not in that state. And we know those are high stress kind of situations, and if we can avoid more, that's better. And And again, that's another way to look at what we're talking about here. What's the point of availability intelligence? It's to introduce a new third state that's possible where you can be fully engaged without being in the panic mode because production users are not yet affected. Response times are still fine, as you can see by the green check mark here, but the risk has changed. Maybe you've lost some redundant components in the infrastructure. Maybe there's some components that are approaching during your peak periods every day, that saturation point where they're going to start to introduce delays into the environment. And then you can decide what's the most logical way to address this. Do you really need some more hardware capacity to deal with this problem? Is there an imbalance across the infrastructure? You can redistribute workloads, so on and so forth. Has there been a change in the application that's caused the workload flavor to be different than what it's been before? Those kind of things. So here's a definition of availability intelligence. What we're talking about, it's to give you the foreknowledge about hidden threats to availability, hidden threats in the infrastructure. And the purpose, of course, is to better protect continuous availability at the primary site by avoiding incidents or by accelerating the resolution of a problem, or really both. I mean, whether you find the problem before it impacts production environment or after, you still got to fix it, and having more intelligence about what's going on in the infrastructure is useful in either of those cases. Most of the time when we think about availability today, it's and protecting availability or continuous availability, it's more about the DR site and perhaps an automated swap solution like GDPS to detect certain situations that have reached that level of a critical nature where it justifies swapping over. But that always has its own risks as well. When you're swapping, and the problem may follow you as well. If you can avoid that, that's fine. When we spend, and rightly so, we spend lots of money on the second data center and the third data center, sometimes the fourth data center these days, to be able to maintain that consistent availability. Our point is it makes sense to spend a relatively small amount of money to protect availability at the primary site in a new way to be able to avoid these critical situations that may cause a swap to a secondary site or an intensive problem-solving session under, a high degree of urgency to get the application back to the proper levels of availability again. And how, of course, is the key question. Why aren't we doing this today? Well, it requires this built-in expert domain knowledge and an automatic analysis of the performance and configuration data. This is how the end result is going to be different than what we've been getting over the last 30 years with how we've been processing the data. So let's talk a little bit more about that. Availability intelligence, it's not enough just to have easier, nicer graphs into the data, or really what the current trend is to use some mathematical processes with the data to analyze it, to recognize anomalies and correlations in the data. There's a whole set of solutions that are available called IPOA, Operation Analytics, that are applying this kind of statistical analysis. And it actually can be useful and helpful in some cases. But it's not enough to produce this kind of intelligence to give you the early warning. It might help you get some alerts about some anomalies that you need to see. So you can also get more false positives this way if there's not enough knowledge about the environment built into the product. Or even worse, besides false positives, would be false negatives, meaning you don't get an alert about something important that's going on that you really need to know about because it's going to cause you a problem if you have a slight growth in your workloads during those peak periods because your infrastructure is not going to handle it. So while statistical analysis is a step forward, in our opinion, it's not enough to produce the kind of intelligence to avoid these issues like we're talking about. So what you need is detailed knowledge about the specific hardware components that are in use. And this particular audience with CMG is strong in the capacity planning disciplines, That's not just about space, but it's also about performance. What are the capabilities of the hardware components to handle the performance requirements of the workloads? And that's a detailed level of expertise that's becoming, it's pretty rare to find what you need across the different parts of the infrastructure to be able to maintain it. There's also best practices about configuration and management of the infrastructure, the component that can be represented with this type of expert knowledge. In our opinion, there's some significant new types of metrics that you can calculate out of the raw data to provide more useful and meaningful information. And the ability of assessing and rating the risk in the data to interpret, is it good or bad? What does it mean? So that's why nicer graphs and charts are not enough. I mean, what do they mean about your workloads on your infrastructure and maintaining the SLAs that your users and business units require? And then finally, another area is just in visualizing the risk and the problems. How do we make it easy to be able to do that, and that requires a certain level of expertise as well. So going down to a deeper level, I want to give you an example in the storage industry. This is where we started many years ago. We've been doing storage performance modeling for over 20 years now. If you have any IBM disk subsystems or even tape subsystems in your environment, you've probably seen some results of some of our products like IntelliMagic, for example, because IBM and IBM Business Partners use that product worldwide when customers are buying hardware to be able to model their particular flavor of workloads on the hardware that IBM is trying to sell to the customer. And it will show the performance you can expect and how long you can expect that performance to be good. That requires a very detailed level of knowledge about the capabilities of the storage infrastructure in use. So it's a great example to show what we're talking about here. HP is also using a version of our product, and we have for modeling disk hardware. And we actually support every hardware vendor that's available for disk storage in the mainframe environment. So what this does here is give you an example of the kinds of things that you can monitor in an automated fashion using this kind of built-in expert knowledge. What everybody is looking at today, typically regarding the storage infrastructure, are the response times coming out of the box. That's what we would call a leg measure. Because it's not something you can influence. It's not a predictive measure of what the response time is going to be. It is what you get. If you want to get this type of advanced warning of problems that are about to occur but not yet affecting the production environment, you need to look more at lead measures. So on the front end of the disk subsystem, you've got things like host adapter utilization. So you have to take into account what specific configuration is. Is it 4 gig adapters or 8 gig, or there's faster adapters now, but the specific make and model will determine essentially how many megabytes per second they can handle during your peak workload periods without introducing delays. So if you have this detailed kind of performance modeling knowledge, you can programmatically evaluate every interval throughout the period for that stage where it's going to start to introduce delays, and then start giving what is truly an early warning, which means before the problem has manifested into the production environment. So adapter utilization or FICON errors is another good example, because the higher speeds in particular, the fiber optic cables are very sensitive to dirty fibers or connections or problems there, and ZOS is actually very good about masking problems until they reach this critical stage where they do affect the overall response times. So people don't notice it until it's already too late. But if you programmatically look at the types of errors and the levels of errors, it can identify issues before they become critical, or even a loss of redundancy. If you have one cable that's pulled, again, most sites are not going to see that. even though the risk of an outage has exponentially gone up. And that's something that you really ought to know about, because if you lose the second link, then you're really in trouble. So these are good things to, good lead measures to monitor on a regular basis. The back end of the storage array is probably these two, the front end and the back end, are really the source. When you have a problem with disk storage, it's generally because of the front end issues on the adapters on the storage array, or the back end disk devices, meaning the actual spinning disks, or even the flash disks, if you've got SSDs in the environment, that they're not able to keep up with the peak workloads that are being required of them for the read and the write activity that you're demanding out of that portion of the infrastructure. Fast write bypass is kind of an emergency D-stage status that these disk subsystems can go into if they're unable to keep up, if the cache levels in the storage array are insufficient to handle the workload. It's going to slow everything down as well. There's other types of things to measure as well within an array, the balance levels across the physical resources. Often we see situations where even a newer environment has plenty of capacity to handle the performance requirements, but the workloads are not well distributed within the components within an array or even between arrays. And seeing application workloads or changes, being able to flag that very easily with some compare charts or differences in the configurations or failures like I was talking about. Those are all things that can produce some visibility into issues that are important to deal with before they get worse. Replication isn't on this chart, but that's another issue that's fairly common to cause unacceptable levels of delay if it's a synchronous replication environment and there's some things that are slowing down between the primary and the secondary. That's going to introduce delays into the service times that the end users are feeling as well. So that's kind of a detailed example of what we're talking about with this kind of availability intelligence and automated monitoring, using the built-in expert knowledge to understand what's important to look at in order to become aware of the issue before it affects the production environment. We've identified 7 different areas of how you can take the machine-generated data, adding this domain knowledge or expertise into each of these areas. And we actually have a set of charts that goes into more detail about that. We don't have time in this particular presentation to go into detail there, but most sites have invested over the years really in adding some expertise in the data collection and development of some reports, the formatting of reports for your particular workloads, your loved workloads. And this is essentially the type of expertise that MXG will provide for you as well on what to collect, what fields to collect, and what reports to generate. But there's a whole nother range that, in our opinion, is really required to be able to get the type of result that we're able to show you with our solution of enriching the data, normalizing it, enriching it, meaning calculating some additional values where needed and appropriate, assessing the data and rating how serious is the assessment of the infrastructure health in providing the normal service levels for those particular workloads, including some built-in recommendations in the product for what to look at to remediate the issue that's been automatically identified, and then, of course, making it easy to visualize what we're talking about regarding the quantification of the risk of the infrastructure to handle the peak workloads. So the benefits, of course, of doing this is what I've already mentioned, being able to avoid incidents, basically translating really a fairly significant percentage of the incidents that are today classified as unpredictable into predictable incidents, and then accelerating the fixes, whether it's predictable or unpredictable, having all of this at your fingertips to be able to clearly see what's going on mean, not everything is obviously going to be predictable. If it's a sudden hardware failure or a backhoe cutting, you know, some fibers or these kind of things, some kind of a power problem or so on and so forth. But there's still significant value in immediately being able to see what changed between this hour and last hour, today and yesterday, or today and the same day last week, so on and so forth, and very quickly drilling down to see what the root cause is. So the sample actions you can take with this kind of visibility is rebalancing the work or fixing the loss redundancy, isolating what the change is, and correcting the error that may have been made. A decision when a problem happens, you call in the, if it's a storage vendor, you call in the storage vendor, and the natural reaction is, well, you need to buy more hardware. That's not always the case, and it's often that there is sufficient physical resources to handle the workloads. It's just another issue instead. So, and it's interesting to look at automating the application of this expert knowledge and how that that can really change the way that you manage the availability or the continuous availability in your primary data center, because being able to assess the risk over every interval for every device or subcomponent in the infrastructure in every single data center and seeing the results all in one sorted list according to severity of risk issues is very powerful. In fact, from my perspective, I would say that it's the only way to continually execute the ITIL definition of capacity management, which talks about considering all of the resources that are required to deliver those IT service levels. And it's not at all feasible to do this in a manual way because of the time involved and because of the difficulty in obtaining the kind of expertise that's required to see how the workloads are being handled by the different infrastructure components. So this is what we do at IntelliMagic. We feel that we're leading in this particular area to provide new types of visibilities of threats to continuous availability. And as I mentioned, I mean, we've been doing some of these things for over 20 years with our performance modeling solution, with IntelliMagic Vision more recently, although that's still been around for quite a few years now. And it's being used by some of the world's largest data centers and some very small ones as well. We break up our IntelliMagic Vision for ZOS product into 3 different groups of capabilities. The first one is on the systems side for processors, WLM, and monitoring workload goals, for example, with some expert knowledge. The coupling facility has been a popular area with our customers to be able to get some deep visibility into that environment and whether there's any inefficiencies or issues that need to be addressed there. XCF and tying in the jobs and data set views so you can easily see what's going on or what's involved. The ZOS disk we've talked about. I mean, with that specific example there's a lot of capabilities in this. This is our deepest set of analysis and reports that we do because of the length of time we've been doing it and the level of detail we go in, including not just the disk hardware itself, but the FICON environment, detailed reports on the specific types of replication that you're using based on your vendors, even interpreting a GDPS record that is cut if you're in that kind of an environment. And then the third most recent module for us is probably with the virtual tape environment. So we've done tape reporting for many years. Again, if you're an IBM tape customer, you've probably seen some output from a product that we have called BatchMagic, and it does some modeling and reporting on the IBM tape environment. And so for years we've reported from a host perspective about your tape workloads and the mounts and dismounts and all this kind of stuff, the amount of work going on. What we're doing now with so far with the IBM virtual tape environment and the Oracle Storage Tech environment is tying in the physical views of what's going on inside of the hardware for those workloads and how well they're handling that, including the replication between the virtual tape devices as well, to be able to monitor that. And we've got some pretty nice success stories of different types of issues we've been able to discover and for different customers, so that they can solve some problems that have been plaguing them for quite a while. So we do expect to support the EMC DLM environment next year as well. That's kind of next on the list for adding that detailed hardware knowledge into the product. And this is interesting, I think, as well for a lot of sites to look at this this problem of making more intelligence about the availability of the infrastructure. How do you create this? It's actually a very good fit for software as a service. So with our solution, you can install it on site. We see customers getting the most value out of it when they actually use our what we call IntelliMagic Vision as a service here. So the data is sent to our servers. Basically, we manage the process of creating the database and the data enrichment and of course adding the expert knowledge into the data and producing the levels of visibility. Then it's available for our experts to also assist in understanding what's going on in the environment, creating remediation strategies for your team. It's available for your team to take a look at, easily distributed because there's a web reporter that makes it quite easy to show what's going on, whether it's the exception reports or dashboard reports or for any particular area of responsibility, from the processor to replication to disk to tape, or for management as well on the high level reports. You can even distribute the reports to your hardware vendors as well to help them get access to what's going on in the environment that you want them to see. So we, of course, frequently update the product all the time. We're coming out with 2 or 3 releases per year to update, the included expert knowledge in there about the hardware or new versions of the hardware that are available. You get very quick time to results after sending us data. I mean, typically within 24 hours, you'll start to see things about your environment that you haven't seen before. And it's very rare that the security departments will produce an issue. Everybody has to check the data, but there's no personal information included. We're getting the infrastructure measurement data about the environment. So that's typically not an issue for the software as a service way of getting access to this. Dissemination, yeah, talked about both of those already. So here's a little bit of what it looks like. And I do want to leave some time for any questions at the end. So I'll go through some of these and then we'll open it up for questions. But this is what we call a dashboard. It's not the top level dashboard. This is for the disk subsystem, but basically on each row in the environment, and we have some of the largest mainframe disk environments in the world as customers. So this can be a longer chart. Typically it's per data center. But it immediately shows you if there's any issues to take a look at, what we call key risk indicators. Instead of a KPI, key problem indicator, risk is an earlier stage. So if the KPI goes off, then it's already affecting your production environment. So in our case, this particular sample doesn't have any yellow on it, but small and green is good, then it turns yellow, and then it turns red, and the bigger the dot, the bigger the incident. We don't rate I/O rates because it is what it is. It helps you see how it's balanced across the environment. But the point here is really within 1 minute, you can see if there's any issues that have developed regarding risk in the infrastructure to handle your workloads that you should be addressing. And if not, if everything is green, you can go on and see, work on other things instead. But if there is, you can drill down and see what's causing the issue. We have a sophisticated rating mechanism to apply this expert knowledge to the different metrics, and some of them don't have any border when you drill down to them, so there's no rating because we don't think it's appropriate. Again, there's a yellow kind of caution as it's approaching a more critical area. Then there's a red, what we would call a performance exception. Either it's already affecting your end users, or it's about, your phone's about to ring, one or the other. Ideally, everything is green, and it's all about understanding what does the data mean for your availability levels. So there's several types of thresholds that we talk about. So this is a throughput chart for a disk subsystem. Throughput is megabytes per second, and these are fixed lines on the back. So you can see there's kind of 3 zones that, and this is the overall disk subsystem. You can drill down to many different areas. I know you can't really read this small print up here, but it's just to give you kind of an idea of how we visualize the rating and the risk in the environment. So the reason these are straight lines is because the hardware is what it is. I mean, we automatically determine what these are based on the configuration, the size of the make and model of the disk subsystem, basically the configuration, what kind of host adapters are on the front end of the box, what kind of disk devices are on the back end of the box, what the bus and processor and cache are like, and this kind of thing. And we then compute what these should be, and we track these, and it's not just a simple violation into the red. As you can see, this one is actually violating the red zone a significant enough time where the whole box is flagged as red. There's another type of workloads that are not fixed lines, but they're dynamic lines. So in this case, the 3 zones are kind of match the workload patterns here. This is for front-end read response time. So the reason this is not fixed is because it really depends. What we expect from the hardware varies based on the type of workload that's there. So random and sequential have different characteristics and expectations from the hardware, for example, or large block and small block I/O, for example. So the product is smart enough to be able to take that into account. It's not going to flag something as red or vice versa as green, just using a simple threshold. So what does it look like in terms of actually being able to avoid a disruption to production that you wouldn't be able to avoid without this kind of technology? Here's just a couple of charts that show an example of this. In this case, this first disk subsystem here, the green, the response time and throughput numbers are green. So basically we're saying that this configuration is able to handle this kind of workload without a problem. You're not stressing the overall limits of the box, and yet there is some yellow and some red in here. So this is a case where you'd have this kind of early warning to say there's something going on here. If I don't deal with it now, it will eventually work its way up here to be a response time issue that our users will likely start to complain about, whether it's ATM's not timing out or whatever the issue might be. So you can drill down and see. In this case, this is a response time chart. Again, you can see these dynamic backgrounds here, and saying this is not a problem. I mean, you're not getting into these zones here where we think you would normally be notified of an issue. Instead, it's very easy and quick to drill down and get a breakdown of the response time components and see how much of the response times are being spent in different areas, who are the largest contributors. And overall, as you drill down, I mean, disconnect time is not out of range for the array, yet the built-in knowledge will help break that down into the different components of disconnect time to show you the queuing and delays, the synchronous copy contribution, and the back-end drive read response time. And if you go back to the top-level chart, that was really one of the things that was flagged as red here, is the drive read response time. So we're saying, from our perspective, this is an issue on this box that needs to be addressed, because it's only going to get worse from this point if these workloads start to grow, because the back-end drives are already becoming saturated and introducing more delays. And of course, pretty much everybody's on a 15-minute interval, or could be smaller interval for RMF. So these are average numbers going up to 32 milliseconds per second or 32 milliseconds in a 15-minute interval is it could be points during that time where it's actually much worse. So this is a case where you want to take some remediation steps to address this issue, either by spreading out the workload across more backends. Maybe the backend drives are just too slow to handle these workloads. Just three more slides here and examples. I'll go through this real quick. This is another example of how to use the intelligence that's built into the database kind of holistically across the environment to look about how to solve a need of a faster execution for jobs. So this is just basically splitting the, looking at the service classes and seeing how much time is spent in each of the areas. You can see there's a lot of time here actually using DASD. So, is that DASD time, using DASD time, is it already kind of best in class? Well, no, it's getting up to 2 to 3 milliseconds of time. It's not best in class. There is room for improvement there. So this requires some services from our team, but it was an interesting exercise that I thought you might be interested in, just to model what is the result of upgrading the CPU for that service class to the best available at that particular time, compared to upgrading it to the next generation of storage unit for this particular workload for this particular customer. So these are the before numbers in the total seconds required for that particular service class. Upgrading to the CPU only produced a 15% improvement, because most of the time was actually using and waiting on DASD. So upgrading, we can model that particular workload on the next generation and see, well, there's a 44% improvement in the runtime numbers just by doing the storage upgrade instead of the CPU upgrade. And most of the time, if you can get the performance win out of the storage infrastructure, it's going to be a lot cheaper way to address the performance requirement than by upgrading the CPU, because of all the ramifications involved with that. All right. This is the conclusion slide. I'll make a couple of comments, and then we'll see if anybody has any questions. If you have a question, you can go ahead and fill out the chat box there with your question. You've already heard these points about the expert knowledge being required, being able to avoid service disruptions and accelerate the fixes. That's the main point. And the thing I'd really like to emphasize here is that it's really a lot faster and easier than you probably think to prove the value of this kind of approach for your site, for your infrastructure, for your data, using IntelliMagic Vision as a service. This software as a service approach is really nice, because it's quick and easy with low commitment on your side, both in terms of the amount of time spent as well as the amount of money. We have multiple customers that started off with just like a 2-month contract to be able to prove the concept before they entered into longer term engagements. So that's available. And that's really the last slide I had. So at this point, Richard, I guess I'd ask if there's any questions that the audience has submitted.
Yeah, Brent, there have been a few that have come in. So the first one, you were just talking about your software as a service option. So what environments do you support with your SaaS option?
Sorry, what size of environments, is that what you said? Or?
Correct. What size of environments do you support with your software as a service option?
Yeah, it's really a fit for any kind of mainframe environment. So we are providing this for one of the largest mainframe sites in the United States, and we're also providing it for much smaller customers. And there's, it works well on any kind of environment, and the value added, not just of the the new visibility and handling all of it for the customers to implement it faster, but I think what a lot of customers are seeing is the value of having access to some of our experts in the various aspects of the infrastructure is very valuable, because we see things that are going on for other customer environments as well, and it's always easier to learn things from other people's experience than having to learn it the hard way yourself. If there's some particular issue going on, there's a number of interesting stories I could tell about some hidden DB2 parameters, for example, affecting I/O response times and transaction failing for a credit card swiping application. I mean, if you can learn about that without having to experience it, it's a lot less pain. So anyway, the short answer is, yeah, it works for really any kind of environment from our perspective.
Okay, so the next question is, most of what you've been talking about is for the the Z environment. What about non-Z environments, like distributed systems?
Yeah. So this was talking about RMF and SMF data, which is obviously ZOS only. For the non-ZOS environments, we do the same kind of thing for the storage infrastructure only. So SAN fabric and SAN storage arrays. And we're very unique in the ability to provide that. And from our perspective, many of the issues associated with performance or service disruptions in the distributed system environments is related to storage. I mean, just because it's typically the least visible part of the infrastructure, it's hardest to see really what's going on. You find out about problems after, they're affecting production like we're talking about. So for the high-end enterprise class storage arrays and switches from Brocade and Cisco, we will monitor that environment, and that's applicable for, really any kind of host environment. So we're not monitoring the servers, but if you're using those kind of storage arrays from IBM or EMC or Hitachi or HP, we can monitor that environment and help you avoid problems in that area. And that's applicable to Windows environments, Linux environments, even the System Z environments that are non-ZOS. So if you're running Linux, for example, on the mainframe, I mean, you're not able to take advantage of RMF and SMF data, but we can provide the same type of protection for the storage infrastructure in that environment.
Okay. So another question that came in. What we're looking at here is sort of this adding your intelligence to the raw measurement data. Is this real time or near time, or is it like 2 days after the fact?
Yep, that's a great question. We get it very frequently, and what we like to say is that it's sooner than real time. So real-time solutions are needed when you have the crisis going on, and you need the data there. And actually, we can add a lot of value in that kind of situation by, like I said, having everything at your fingertips. But it's not real time in the sense that every minute we're getting updated. We're dependent upon, in this case, the RMF and SMF data and the intervals that you're producing that on. You can load it in so it's near real time if you want to look at the last hour. But what I'd like to stress in this is that when you get visibility early before the response times come up, you can avoid those real-time firefighting incidents. I mean, that's the objective as much as possible. So we have one of our customers is a stock trading company, and they had an incident, and they said, we really need a real-time solution because at 9 o'clock stock market opens. We had this issue, and we can't be looking at yesterday's data or even last hour's data. We need to know right now what's going on. Well, we got the historical data from them from 2 days prior to when they had that incident at 9 o'clock in the morning, and our dashboard was already showing that they had issues or stress or risk in the infrastructure. In this case, it was a disk storage situation that would have given them advance warning to know that, that third day, they just had a little spike in the workload compared to the day before, but it hit the knee of the curve where response times went up and caused a lot of big problems for them. So the answer is no, it's not real time. It can be near real time, but even better, it can be sooner than real time. So hopefully that makes sense.
Okay, so another question that came in. How does this software hook into your environment? Do you have agents? Do you have to install software on each of the ZOS boxes? So how does it hook in?
Well, yeah, it's actually a low overhead process because we're dependent upon the RMF and SMF data. So it's a post-production environment. You don't have to install new agents to intercept the SMF data as it's being written. That's a very, that's a pretty CPU-intensive kind of approach to solving this problem. We take the data. Typically, our customers do it once per day. As I said, it can be more near real time if you like, but in practice, they've found that they get the visibility they need by getting the data once a day, and we go through this process of adding the expert knowledge, building the data and the reports, and so on. So it's extremely easy if you go the software as a service route, but everything can be automated, of course, through jobs if you do it on site as well. The repository, the PDB, if you will it can be on a server, a SQL server, or it can actually be on the ZOS platform itself using DB2.
Okay, and I think we got a couple more quick questions. So, do your customers want to add their own rules to your expert domain knowledge?
That's a great question, and we love it because those are the kind of customers that we like that help make the product better. So the answer is yes, they do. You can actually modify the rules as well if you feel that some of the ways we've done them are not appropriate for your particular situation. In other words, you don't want the dashboard for this particular part of the environment to go in red. You know, you know what's going on there, you're okay with it, or vice versa. I mean, these loved workloads have higher sensitivity levels. I mean, there's things you can do to tweak it already. The additional rules are something that we tend to work with customers on, and we pride ourselves on being responsive for adding requests into the product. So we've just gone through a round with a large financial services company, actually in the processor side, regarding RNI and TLB kind of reports for their Z13 environments. So the answer is kind of you can't add new rules. You can modify the current rules. It's more difficult to add the rules, new rules for interpreting new record types and this kind of thing. But we're continually improving the product and would love to understand the requirements, and we feel that if one customer needs it, more than likely every customer could benefit from that. So that tends to be our approach.
Okay, and the last question, and I think this is related to the real-time or near-time. So the question is, can your processing be streamed instead of batched?
Yeah, so probably that's using like log streams, and I think right now it's mostly a batch kind of process, but I know that, Jerry, do you have any information on that? Jerry Street is on as well. He's one of our technical consultants who was here to back me up, and I know we've been making some changes in the architecture to allow more additional options for more real-time service, and whether that's via log streams or some other source. I don't know.
They covered that a little bit in our annual meetings, and it's on the roadmap, and it's probably getting close, but they don't have any dates. But that's certainly something that we've heard loud and clear from the customers and want to implement in the product. So it's on the roadmap.
Okay, good.
Okay, and I think that was about it for the questions, and we're almost at the top of the hour. So Brent, okay. I want to thank you and IntelliMagic for sponsoring this webinar. It was interesting. It's neat to see kind of this intelligence being added to the old, boring data analysis. You know, it's adding more smarts to help us do our jobs more effectively.
Right.
So the final slide here is announcing the CMG International Conference. It's early next month, San Antonio, Texas. You can still register. You can still get rooms, and we would love to see you there. And I just heard at the beginning of this webinar that IntelliMagic is going to have 8 sessions at the conference. So if you want to hear more, come join us next month in San Antonio.
Yeah, including our founder and CEO, Dr. Gilbert Hautekamer. He's the co-author with Pat Artis of the book MVS IO Subsystems, so a lot of folks kind of recognize that name. He serves as our main architect of the product, so he's doing a product kind of training session and some other sessions as well, but he'll be at the conference. We hope as many people as possible can be there.
And the recording and this PowerPoint will be available on the CMG website. We're hoping by the end of this week. So once again, thank you for joining us today, and have a nice Monday. Thank you now.
Bye-bye.
Bye now.